Okay, this is a problem that we did about an inclined plane, a simple problem of something sliding down a frictionless plane. And the plane was inclined at some angle theta above the horizontal. And the question was to find the acceleration. And we're going to apply the method that always works. We're going to start by choosing the object. And then we're going to draw the forces on the object, not by the object, on the object. And so we have the force of gravity, which is mg downward, and we have the normal force. We don't know anything about its magnitude yet, but we do know that it is perpendicular to the surface. If we choose axes that go x and y like this, that means that we need to take the gravity vector and separate it into components. So one component in the x direction and one in the y direction, where the vector itself, that's the hypotenuse. And now this angle is theta. Okay, the next step is to write down that the sum of the forces in the x direction is a bunch of stuff, and the sum of the forces in the y direction. In the x direction, we have mg sine theta, and that's it. That's the only force in the x direction. In the y direction, we have the normal force is going upward, and in the minus y direction, we have mg cosine theta. Now, the sum of the forces is equal to ma, that's Newton's second law. The sum of the forces on the object is mass times the acceleration of the object. Well, it doesn't have any acceleration in the y direction, so we know that's 0. And we know just from the statement of the problem that the object was accelerating down the slope. Notice that I don't draw the acceleration as a force vector. It's not a force, it's just an acceleration. So it actually goes on the right-hand side. To find the acceleration, we just use the top equation. We notice that the masses can be divided out from both sides, and we get that A is equal to g sine of theta. And that's the answer, which means that if we wanted to stop this thing from moving, we could apply a force of mg sine theta back up the ramp, and that would keep this thing from sliding. Okay, as we showed in class, you can use different axes, but you should get the same answer, and I encourage you to try that.